great title I've come up with is Drizzle 7 GA and supported current and future features, otherwise known as I wanted a title that's a bit more exciting and different than just plain Drizzle database for cloud. So we call it Drizzle 7. Why? Because 7 is a great number for a first GA release, because 7 is quite high. It's not like 1.0, so it implies a little bit of maturity. Plus, it's a little bit higher than a bunch of other database version numbers, but like not as high as some others. So we're not, too egotistical. It's a nice middle number. And Drupal would do Drupal 7 at the same time, so it seemed like a nice kind of symmetry going on there with the number 7. Plus, Prime. And if you think that wasn't a consideration, that's, you're completely wrong.
Maybe people will be looking for Drupal 7 and I'll still Drizzle by mistake and then realise how good it is.
Exactly, we hope so, because it's completely not the same thing. So it will no doubt create confusion where previously there was none. And I also want to talk a bit about the fact that we've been working on Drizzle now for a while, since 2008, and for a while we're going, no, please don't use it yet, where upgrades may not work and all that kind of stuff. But we're actually at the point now where we can say, yep, go ahead, we're pretty confident this will work for you properly. We've hammered it pretty solidly and we're pretty happy. And so we're at that kind of stage where we're saying, yes, we have good confidence this will not horribly explode for you. And so we call a GA release being, go right ahead and give it a go. Supported, of course, means that not only that random hackers around the world are hacking on it, but also there's actually a number of companies behind providing support. So the Drizzle project now is started in 2008, is a database server. It is for POSIX-like systems and the like, and we declared GA release back start of the year, which is great because it's always good to have something you say, yes, we're ready, we'll support upgrades and all that kind of thing. We did have people using Drizzle in production way before we said GA, as in like even really soon after we did the first announcement of, hey, we've created this branch called Drizzle.
We're getting confusion on what GA stands for.
Generally available, general availability release, like stable, non-beta, gold. Gah, yeah. But yeah, we had people using it in production like really soon after, like before we'd fixed the SQL dump tool to actually work properly. So people are like, well, I downloaded the BZR source tree from file that benchmarked it, it was faster, so I deployed it. Which is a great thing to go for random snapshots of the source tree, but definitely now we're at a much better, more stable position than that. I work for a company called Percona. It does performance consulting for the whole levels of the web stack, so primarily focusing on databases, that is MySQL, that's what we see most often. Also providing support, consulting, services, and everything around Drizzle as well. So we have a tremendous amount of knowledge there. There's my commercial plug. Done. Back to the hacking. So, Drizzle. A couple of things to do with Drizzle, which are quite different from existing relational database servers. Very much focused on pluggability. The idea is that, everything is a plugin, or everything is a module. Everything should be a component spoken to through an API. This doesn't have to be sort of a public out to the client API, but something internally that makes amount of sense. It doesn't have to be stable. So think of this about Linux kernel and kernel modules, right? Same kind of idea. You have a core kernel that's core and must work and has some complicated bits in it, and most of the rest of the functionality that you really care about can sort of be bolted on as you want or as you don't want. So load what you want, load what you don't want. This has the benefit of we're trying to reduce the core of the database server down to a kernel that could be understandable by one single human being. One of the problems if you look at a bunch of database server source code is you have these giant monolithic code bases that pretty soon you realize that you will never understand the entirety of. And you'll always, the likelihood of you missing something because you don't completely understand how this particular part of this bit of storage and replication works is problematic. So one thing we wanted to do is focus on making it pluggable so we could avoid a bunch of those problems. We wanted to make it infrastructure aware. And one of these things is making it pluggable is like, the database server is no longer one big golden island of the center of all known knowledge and everyone must hail the almighty database. That's not what it is anymore. We don't have everyone sitting at VT100 terminals to the one true mainframe running the one true database typing in SQL queries by hand. At least I hope not. Does anyone have a VT100 that they enter SQL queries on? No, exactly. What you have is a large set of infrastructure in an organization or in an app. So you have bits that are application servers. You have maybe data storage server. You have file server. You have all these bits sitting around here. Then you have runs running like MapReduce jobs everywhere. You have like a Gearman running distributed job queues. You have existing infrastructure, and the database has been this sort of island into itself, where it's like, well, I already have like authentication stuff here in, be it LDAP or Active Directory or something, or heck, HT password files, or etc. shadow somewhere. You have that. Why do I then have to have the copy of that inside the database? Well, maybe your app doesn't actually bother to authenticate to the database. The app always connects with the same username and password to the database server and does with it. So basically, you're just wasting time. We want it to be infrastructure aware, where the database server fits into your existing infrastructure rather than dictate it. So we didn't want it to have to be the almighty database everyone must worship. We want it to plug in at the appropriate points and just work. As in, use existing logging functionality, use existing authentication. Just be a part of the infrastructure, not something that's out there to deal with this silly database server. Community developed. We want it very much to be a community project that was an open source project that was all out in the open. There is no secret hidden mailing list. It just doesn't exist. Basically everything's on IRC, mailing list, Launchpad, everything's out there in the open. There is, everyone's on the same level. There is, the person who controls, what finally gets into the tree after it goes through regression testing, and everyone else, always just sends merge requests. So it's everyone's an equal playing field. We wanted to focus on multi-core scalability. Who knows where you can buy a single core CPU in a server?
eBay.
eBay, yes. It's like you cannot have less than like 2 cores at least. People have much more. 48 cores is something that we see increasingly out in the wild in a server that's not that expensive, and we'll just see even more of them. So therefore, you must now be able to actually use or have a hope of starting to use 48 CPU cores. We wanted to focus on concurrency. We wanted to focus on being able to do lots of things at once and get them done within reasonable time. So this, of course, mmeans no giant global mutexes that you hold for a long time. We wanted to focus on the web. We wanted to focus on modern web applications and how they use the database. So we're not talking about, hey, this should work really well for executing this long analytical query that's going to take 4 days to execute across 34 CPUs and 140 machines. Not what we're focusing on. There are other systems that are much better than that. And trying to be sort of okay at all trades and master of none, not what we're interested in. We wanted to enable others, so we wanted to have it very much to enable others to be able to contribute to the project, to be able to use it, to be able to build businesses around it as well. We wanted to be able to have a modern code base. That is, we wanted to have a code base that any reasonable, even beginner, intermediate, advanced, C++ hacker could get into and actually see how things work, understand how the server runs, how parts of the server works, and even write plugins in there. So you can actually be, kind of I hack sometimes C++ and still actually do something inside the database that's useful, or read it and understand what's going on. So when we forked from MySQL, one of the big things we did was a lot of refactoring. Refactored things, make it look like modern code, make it readable, understandable by humans, have nice interfaces and have good boundaries between interfaces between it. So instead of having a horribly layering violation spaghetti, have clear layers without server. We have a couple of values in the project. We're very much about open and documented interfaces. This is part about refactoring the code base and getting into a modern C++ code base using things like the STL, using things like Boost, using things like protobuf library and libevent and everything there. Is we wanted to have everything open, documented out there so that anyone can come along and understand how the internals work. We very much wanted to have sane interfaces, sane inside the server and sane outside the server. So we wanted, for example, to have -p on the command line on the client actually mean port and not like password, which is just like make it behave like every single other Unix utility out there that expects a password, not be odd. We wanted to also have it very much sane from a SQL point of view. Don't accept bad data, don't accept rubbish in there. And we also wanted to be transparent, as in community project, everything out there in the open, no secret in club and the rest of people. Of course, we wanted to have a lot of fun doing it, which it is. Hacking out a database server can be a surprising amount of fun. Very much about collaboration, lots of people working on it together, true open source community, participation, lots of people come up and do their various things, scratch their itch and the like, and you end up with a nice community around it. Very much wanted to enable people to be able to build businesses around it. So we see this with people providing support and consulting, like Percona, who I work for, does. Aryan, wherever it is, we'll also talk about Drizzle if you ask him as well at OpenQuery. SkySQL provides support for it as well. And we see other ones coming up as well that I can't say names yet publicly, of doing some pretty cool things to build businesses around Drizzle. We also had a huge focus on testing. So it turns out that a database server is a really hard thing to test. You can think of this of like, if I bang in these 5 SQL queries, I should get the same result in the new version as I did for the old one, right? It turns out that's a very, very basic testing. For example, as soon as you get things like joins and subqueries and the like, and any feature that you'd expect a relational database to have, you start sort of adding a lot of different code paths that could be taken in various ways through there. So we had a big amount of investment on testing infrastructure, and actually we continue to pump resources into that to be able to test the database in new interesting ways. And one of this is using something called the RandGen, which is basically a random query generator. You provide a Yak-like grammar, and instead of parsing queries, it generates queries that fit the grammar, and then throws them to the database server, and then automatically, like when it crashes, not if, when, it will then try and pare down the test case to produce a minimum set of queries and data that will cause the database server to crash. It will also do things comparing, so say, hey, compare against this other server, so it'll generate the same set of random queries, bang it against 2 servers and check if they get the same results. And you can do other kind of validation there. It's lovely and modular and wonderful, and basically it has been responsible itself in killing at least 2 products, simply because they were so buggy it was embarrassing. We've also had this situation where it's like, hey, someone says, magical scalable solution, drop in replacement, throw in RandGen at it, then come back and gone, I don't even know if we can reasonably write that blog post out there, because it comes off of basically, your stuff is so broken it's not funny. Simple queries either crash the server, don't scale at all, or return the wrong number of rows. We've seen this on a couple of products out there. Yeah, not even the contents of the rows is wrong, but from the query, the number of rows returned is wrong, which is even more testing, even more interesting. And testing is a big part of what we do. Very much automated, including performance regression testing, something big we wanted to do. Cool. Why? We wanted to rethink everything. We don't want to catch up with other systems, we want to leap forward. So this means, of course, only focus on 64-bit. Yes, we run on 32-bit, but if something works better for 64, we go with that. Lots of RAM, right? All machines now running database servers have a fair amount of RAM. We don't need to scrimp and save, 1, 2K everywhere. We can, in fact, use memory to enable higher concurrency. We can just copy something instead of having to grab mutexes. UTF-8. The web is UTF-8. It is not EBCDIC, it is not funny character set foo here. Everything is UTF-8. Modular architecture, of course, because sometimes you don't want people to do certain things, right? Maybe you don't want them to use stored procedures, therefore don't load a module that does stored procedures. Of course, we wanted to keep the existing storage engine interface, and we've cleaned that up a whole bunch, so it actually internally inside the code is much more obvious. For example, there is a simple call that is begin transaction, and that's called when starting a transaction. It's pretty radical stuff, having clear APIs in there, which aids to a whole bunch of less bugs in the server. So we actually have code inside that sort of helps us ensure the end result is correct. Functions, every single function, like, count, sum, MD5, all those kind of things that you can call are all plugins. So therefore, if you don't want people to be able to do certain things with functions, don't load them. Replication, entirely modular replication system. We completely replace the replication. We have some really cool things inside replication. For a start, you can store the replication log inside InnoDB. So instead of having to sync between a replication log and a transaction log, you actually just write it once. So transaction commit becomes a single fsync that changes the transaction, as well as the details to be able to replicate that on another server. And so you think, wait, doesn't that mean you're storing the same data twice? No, but we're only doing one fsync. We're not doing a 2-phase commit with another file. So this gives us actually a huge performance boost. And it's also pluggable. So if you want to replicate through your magic foo that you think's better, write a plugin for it. It's not that hard. The slave plugin, the initial slave implementation for Drizzle was 20 lines of Python. It is a documented data format we ship out. Logging, of course, pluggable. Use syslog, use out to the console, use anything you want. You can go something that takes it over Twitter if you want. Authentication, of course, pluggable. We have a PAM. Also, you can use any of the PAM methods that you want. We have HTTP, so it can do HTTP auth for authenticating database users, which is actually written by one of the cloud providers. That's how they do authentication. And of course, the network protocol is pluggable. So you can speak, we speak MySQL protocol. We're working on something we call the Drizzle protocol, which is an improved version that can also speak that. And we have like the beginnings of stuff like HTTP, JSON, foo coming up. Some bits of the parser are pluggable. We hope to have more in the future. We have this idea of virtual tables. So if anyone's used MySQL's information schema, maybe, and then hit performance limitations on it because it creates temporary tables and fills everything and then runs conditions and just maybe haven't noticed. Yeah, so we have this wonderful internal interface that makes it very easy to traverse in-memory data structures inside the server and expose that out as tables without having to create a temporary copy of that table on disk first. So for example, when you select star from Drizzle's information schema tables, it basically traverses the list of tables in the database and returns the rows one at a time. It doesn't then write a file to disk which contains the 200,000 tables you have in your database server and then, does the where clause on that. It doesn't do that. We have this idea called sort of internal triggers or row events, which let you do interesting things like write a module inside the server that uploads all the blobs to S3. There's one of those in there, or this is what's used to do the replication infrastructure. So we actually have interfaces that we put inside the core of the server is used for running our plugins. That makes things very, very easy to write. Cool. We have a few normal standard features in Drizzle as well. It is of course transactional. We use InnoDB by default. As I mentioned, we do logging to syslog. We also have replication be pluggable. There's also a replication plugin that throws it out to RabbitMQ, so it's a job queue system. So you throw the replication log out there and you can have something else consume it. So you suddenly have this interesting idea when you have a pluggable, documented replication log format, you can have consumers of this. So if you want to then run something, for example, if you're storing the database download stats, you could then have something consume the download stats as they come in, then maybe do GOP lookups, and then send and construct an on-the-fly map of where people are downloading things from. You can do this by consuming the replication log, so you don't have to then do other weird foo in there. You can start treating events, data change events in the database server as something that can asynchronously be processed as data by other processes, which is pretty cool. Auth, PAM, does anyone ever need anything else? Apart from PAM, probably not. Strict mode. MySQL has this thing called strict mode, which in other words is don't insert rubbish data into the database. Guess what? If a column is not null, we don't allow you to insert null into it. If you have an enum that says value A, B, and C, we don't allow you to insert 0. We throw in it. If you write an integer that is too big for the form of the field, guess what? We throw in error. No bad data. Pardon? 30th of February. 30th of February. Should be an error. Right, no bad data. We have a data migration tool, which is basically Drizzle dump can connect to existing MySQL server, suck out the data, convert the data types, try and do something sane with the corrupt data you have, and then convert it to Drizzle. So there is actually some data migration tool to help you migrate across. Most of all the DML language is pretty much the same. There's a few things we don't have. We don't have SQL 2003 stored procedures. Yeah, no one complains. We don't do triggers. And we don't do views currently, mainly because we didn't like the way they were implemented inside the server. We do want to bring views back, but we want to do that as part of query rewriting instead of the funny way that was done inside the MySQL server. We also want to do that for partitioning as well, so it becomes a bit more of a query rewrite engine and less of a let's fake it that there's actually a table there because we want good query optimization, which is a lot of fun. What new and future things do we have coming? We have improved multi-tenancy support. That is a work in progress. This is one that always gets shuffled along to a bit of the background, just because there's a million and one other things to work on. Basically, the idea is that we have this extra layer called catalog. So catalog / schema / table instead of just schema / table. And this basically allows you to sort of partition off users into their own playground. So normally when people are doing multi-tenanted MySQL or anything else, generally what they do is, right, this user gets a database of this name, and you can only store tables in that one. And if you want to create a different database because you have 2 apps or something, then you have to either go through something else that we wrote that gives you a username prefix to the database name or whatever, and you have to use our specific one username that we gave you and other such foo. The idea behind catalogs is the fact that you could just give people essentially a virtual database server with virtualization done inside the database server rather than at the OS level. So instead of running multiple database servers, the database server just handles that for you. So you could have your own set of authentication per user, do your own set of schemas and everything, and do your whole kind of nice partitioned off, happy, fun place that you want to be, with a much less performance impact on having a multi-tenanted database. For example, now I run 10 database instances on the one server, and you do a commit to each one. That's actually 10 writes to disk. You can't do group commits across database server instances. Guess what? With this, we could actually do group commit inside the one database server across all multi-tenant users, which would be fairly neat. So that is a work in progress, and hopefully one day it'll be finished. We've spent a lot of time laying the groundwork for this. Basically wanted to clean up a whole bunch of internal interfaces to make it even possible, which took a long time. XTrabackup, so this is online non-blocking backup for InnoDB. It's actually, I did write this slide before I joined Percona even, but it is actually a Percona product that we do. Open source, completely out there, great little tool for backing up InnoDB tables from MySQL as well. We also have a port of it inside for Drizzle, which is fairly cool. We also are working on a JSON interface, so a little web server that explodes it there. Another cool patch that I just got in was actually the startings of stored procedures in JavaScript. So you actually execute JavaScript database server side to do some cool foo if you want to do that, which starts to get actually interesting because think how many people know SQL 2003 stored procedure language? Not even me, and I've worked on database servers for all my professional life. So, you know, no one actually knows this. Who here can actually write bits of JavaScript? Exactly. Point taken. That's what you want to write stuff in. It's what you're doing for the web anyway. We've also incorporated a bunch of the Percona InnoDB patches that improve like performance and scalability of InnoDB inside Drizzle. So we have a pretty exciting future going on with what's coming up. Definitely this next release that we're currently in beta is focused on fixing up various bugs and more stability improvements and the like, making it a more mature product. But we're definitely at the point where it is actually a very exciting thing to start looking at and use. Not just saying, hey, there's this thing I'm looking at for the future. We're definitely at the point where it's like, you can use this now. It's pretty solid. We have not had, too many like catastrophic bugs come in, which is always a nice thing. We've actually tested it fairly extensively. It does do nice things for you. No bad data, always a plus. Multi-core scalability, UTF-8. You may think your app works fine with UTF-8. Odds are, if you don't speak a language that is non-Latin characters, something's wrong. Cool. So that is a very quick update on where we are with Drizzle. And thank you, and I'll happily take questions if people have them too. Yes?
You talked about, this probably sounds actually really easy, like you said, that keeping a lot of databases might have a lot of reads and maybe quite a lot of servers and less so that's what you're building. And if you want to get the biggest issue about replication, otherwise there's an update here, then get replicated over here, so you've got code running, you just replicate your bad data, so you've got to have it backup.
Yep.
But could you use the replication space there to push the log back as well for another keyboard changes, assuming you've got this space?
Yeah. Yeah, I mean, you can consume the replication log however you want, and you can easily introduce delays in there. You can actually even back up the server at various points in time. Doing extra backup will do incremental backups as well, and that will be improving the way it does it. Currently, it does a full scan to find which pages have changed, but soon it will actually do a real sort of incremental thing, which will be fairly neat. So you could also do that and sort of help you to quickly go back in time.
Extra backup does it as the binary format, doesn't it?
Yeah. So our replication log is, of course, row-based. It's not statement-based because that can never work. By definition, statement-based replication cannot work if you allow more than one connection. Interesting side note. And we avoid a whole bunch of locks actually by doing row-based replication. So you get all insert, update, delete records there. So you could, in fact, you could sort of play in reverse order if we store absolutely everything you need to do that, which I can't remember. But it's possible. That would be a cool project. Go backwards in time. Cool. Quick question.
MySQL has InnoDB files for the server or the table. Is Drizzle thinking of having different levels, which makes sense an InnoDB file for a schema or a catalog?
That wouldn't be too hard to add. So InnoDB itself doesn't really care where the table's stored. It's basically you specify that at creation time. So actually adding that feature would not be too much effort. But we have thought about it, we haven't implemented it yet.
The catalog level would be good.
Yep.
So
When we get catalog support done, yep.
as an increment, the schema level would be very nice too.
Yeah, I think definitely for the fact the schema level would be great. I mean, one of the downsides of file per table is the fact that then when you're syncing things to disk, you have many more files to sync and many more files to open.
Yeah.
But yeah.
I asked you, you know, this question, whatever not, but I noticed that there was a lot of talk about with Drizzle and Drizzle and do you know any of that's wrong?
There is patches there to make Drupal work with Drizzle. There was, what is the current status? Periodically you go and check it. It's really annoying. The Drupal bug tracker won't send you an email.
Yeah.
It's like, I have to go and poll a website.
Yeah.
So, someone fix that, please. But last I checked, there was work in progress. It still did work on 7 and wasn't completed in time for the final 7 release. So maybe we're working on the next version there. And there was 1 or 2 things that were, I think, addition that I need to be fixing inside Drupal. But basically, the key changes in 7 to get more database agnostic helped a lot. So hopefully it's released soon. Hopefully. Then I can run Drupal. So we hope.
Last couple of questions.
No?
Cool. You talked about query rewriting for views. That's what Postgres does, right?
I am actually not sure.
So Postgres has query rewriting that lets, it has a view statement and it rewrites the view statement to be a query rewriting statement, which is, is alternative. And you can do query rewriting to create writable views as well.
Ah, yes.
So you create writable views to kind of do the Postgres specific magic. Is that the sort of thing you'd be looking at doing?
Yeah, so similar idea of basically, hopefully we get it to a point where it doesn't actually, insert the SQL and then parse it all, but rather actually, has sort of a pre-pass tree and inserts the bit of the tree of the tree to execute. Hopefully we get to that point and system optimized. We have a current sort of query rewrite API inside Drizzle. It's a very crude one. It's basically, here's the SQL string the user set, now give us back a string that they actually mean, which is pretty crude, but actually does work for some interesting use cases. Yeah, basically we look at something where it does actually insert the SQL back in.
And the one step beyond that is, I guess, materialized views.
Yeah. Materialized views are actually probably not too hard to implement inside Drizzle because we already have the role event interface that will get off the appropriate tables. The only thing is then you have to do deal with it for all possible join conditions alike. So doing the simple materialized view would be really easy. Doing sort of complex ones with lots of joins starts to be a bit harder to be able to do. It becomes a larger project. Hopefully at some point. I mean, materialized views are hard, and writable views can also be interesting. But yeah, one thing we did want to do is not have views be just a sore point entirely to the optimizer. One of the problems we had is that a bunch of the data structures inside to represent, path queries and optimized queries don't always have the best APIs internally, or have pretty odd semantics somewhere. And we wanted to get that to a much cleaner point before we started writing this. So we wanted to get something to a solid base level of an API and then do it. And this proved, a problematic replication. For a while we had no replication answer whatsoever because we're reworking the underlying component first. And then when we finally had that, like writing the replication log in InnoDB was like a 1-week project rather than, 4 months.
You might want to take a look at the syntax that Postgres has for their query design.
Yeah.
It's been around for quite a while now.
Yeah. Interesting.
Okay, so we'll have to end it there. Please thanks to you.
Thank you.